This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 115, a look at what is new in mechanical electronics reliability in Ansys Sherlock 2023 R1 and a review of news and events in the world of Ansys. Welcome to our little podcast, episode 115. I'm glad you could join us. My name is Eric Miller, and I'm one of the owners here at PADT and your host for these podcasts. I need to apologize. This is my first day back after 7 days off from work. That's actually 9 if you include the weekends. Actually, 9, 10, 11 if you include the weekends. I went on my third Star Trek cruise with 2 friends, and it was so much fun. I highly recommend it. If you're a Star Trek fan, it is really a blast. Great time. Just Google Star Trek The Cruise to learn more about it. I don't get paid for that, but I am spreading the word. But I have to admit, I don't recover from a 7-day nonstop Nerdfest party like I used to. So I'm dragging a little bit and a little discombobulated, as you'll see as we go through this. I did try to get one of the celebrities to do a plug for All Things Ansys. No go. They wouldn't do it. But I did meet a couple of people with Star Trek podcasts out there, and we will try and arrange a crossover at some point in some way or some kind. So anyway, the podcast itself is doing well. We took that very long break, but people are still downloading episodes at about the same rate as before we took that break. In fact, episode 113, which is our return episode, had more than normal downloads, which is great. So please do share the word and let others know about about our little show and how much you like it. We are at 38,100 downloads across 114 episodes today, and I hope to get to 40,000 by mid-year. So that's a good goal to shoot for. So a little preamble here before we dive into the interview. We're talking with Josh about Sherlock for this episode. We've talked to him about the product before. And I do have to apologize. Like I said, I was a bit befuddled and a little discombobulated and sent one out once or twice. And I did talk over Josh a little bit. He was getting a little frustrated with me, but he handled me like the pro he is and delivered the information that I know you want to hear. So let's go ahead and move on to that. I want to welcome everybody to our discussion today with Josh Stout about the Ansys mechanical reliability products for electronics. How you doing, Josh?
I'm doing well, Eric. Thanks for having me on.
Thank you for being with us on this nice day here in Phoenix. We're in between storms, so our cold winter is cold for us, so we're enjoying the weather. So, let's just dive right into it. We're talking about Sherlock. We're talking about what's new in 2023 R1. So what's your favorite thing that you want people to know about right off the bat?
So favorite thing right off the bat for Sherlock is always going to be how Sherlock talks to other tools for me. It has lived within the Workbench environment for a couple of releases now, and they keep adding new things to it. But the biggest part of that for this release is more in-depth support for multi-board workflows. So a lot of times when we're working on something in Sherlock, you bring it in one board at a time, you do some post-processing, and then you kind of assemble things after the fact. But one of the really nice things about a Workbench is that you can put it all in the same platform, I guess. So much easier to keep track of things, much easier to organize them. And then what's new this time is that we can actually combine things in Workbench. So it's not just organization anymore. It's actually taking 2 boards and 2 different Sherlock projects and combining them into a single model. And we can run whatever analysis we need, whether it be thermal or mechanical or vibration. And then we can split those results back up in a Sherlock post. Great. So Sherlock then knows how to interpret each of those boards on its own with the corresponding stresses, strains, in order to do the full reliability study. So it's just becoming more and more powerful. It's very good.
Easy, powerful. Good. Yeah, I probably should have started with this, but some of our listeners may not know. We've talked about Sherlock a couple times, so I didn't think about it, but maybe just very high level, let the listeners know who aren't familiar, what is Sherlock? How is it different from Ansys Mechanical as a tool for electronics reliability?
Very good point. So when we're talking about electronics reliability, there are several aspects to it. One is electrical reliability, which is not strictly what we're talking about today, but basically doesn't work electrically. And then there's thermal reliability. So is it too hot? Is it too cold? And how does it react to that? And then mechanical reliability is everything around stresses and strains on a board. So that can influence solder joints. It can influence specific failure mechanisms of like capacitors versus resistors versus integrated circuits. Might affect trace models if they're delaminating or something like that. But a lot of that has to do with how is the board mounted in the chassis? How well secured is it? How does that react to a vibration environment? So like if it's on a truck or on a spaceship or a rocket, something like that, it's being shaken around, has stress and strains associated with that. Or maybe it's a cell phone that we drop and the PCB has a shock that goes through it. So a mechanical shock, I mean.
And
so
this was
that,
go ahead,
yeah.
finish up. Yeah.
So that's all under the mechanical reliability umbrella.
Right.
And the overarching theme here is that when we talk about Sherlock, we're looking at mechanical reliability.
Right. Okay.
So
good.
Just sorry. So just to completely wrap that up, Sherlock is a preprocessor and a post-processor. So we give it ECAD information for PCBs, and it generates this model that we can run all of these analysis on, whether that's the vibration or static structural or thermal or whatever's related to mechanical. And then we take those results back into Sherlock, and Sherlock tells us, is this board going to survive whatever we put it through?
Okay,
so
very good.
That's the idea.
Okay. Yeah, and Ansys acquired them a couple of years ago, right? It was a third-party product, and I think the integration with Icepak is a great example of how Ansys is taking, when they acquire a company like this, which is very kind of a niche tool, and integrate it into the bigger picture of the Ansys suite, including working with like CFD tools and thermal tools and things like that. So I love to see this. I'm always very proud of how Ansys that when we meet with customers, it's like, because a lot of our competitors will buy a company and just kind of put it on the shelf. You can buy it from us now, right? And there's no value add of the acquisition. I'm really pleased with how this one's going, especially. So good stuff.
Definitely.
So what else is new and exciting in there?
Yeah, so you had mentioned Icepak specifically. That is the tool that we use for thermal studies, especially on electronics components like PCBs pretty frequently. So that's one of the examples here that Ansys has really improved Sherlock with. We used to be pretty limited as far as what assumptions we'd make thermally in our system. So you might say component 1 on the board has a temperature rise of X and component 2 has a temperature rise of Y. And those would basically just be, uniform temperatures, really basic assumptions. And you can certainly get some, useful information out of that, but it's not as accurate as it could have been.
Right.
So one of the things that they're doing in this release, 23R1, is they have added some kind of bidirectional communication with Icepak.
Okay.
So we can use Sherlock to generate the model that goes into Icepak, and then we can run a super detailed thermal analysis on the entire PCB and enclosure, whatever we need. And then we can bring that back into Sherlock as a temperature map, basically.
And this is getting into the weeds a little bit, but can I then do like thermal cycling? Say for a ball grid array, I can just say that this is the high temperature, this is the low temperature. Go ahead and tell me what the fatigue is going to be on that.
Exactly. Yeah, that's the whole point of bringing in temperatures.
Okay.
So if we have the more detailed map when we run that thermal cycle sort of fatigue analysis, then we get better results from it.
Great. Yeah, so back in the day when I actually did a simulation, that was one of the things we used to do a lot of, and it was very manual and a real pain in the butt. So I'm glad to see that we've come a long way. It's good. Okay, good. So any changes to the user interface that users should be aware of?
I'd say user interface has remained pretty consistent,
stable?
which I think that's generally a good thing.
Yep.
I mean, it does what it needs to do. You know where everything is located, once you learn it. So no major surprises there.
Good.
I guess on kind of the user interface side of things, they have been integrating more closely with some of the Ansys Python APIs.
Very good.
So that's something I haven't gotten into in too much depth just yet. But they added some new API connections this time around. So if your preferred user interface is more text, then you might be very interested in that.
Yeah, we're really they're really it's really taking off. The whole Python interface, API interface, is really taking off across Ansys products. If you're a reader of our blog, you'll notice that Alex and some other folks have written articles on the various PyAnsys things, mostly around mechanical, but some other stuff around mechanical APDL and post processing as well. And highly recommend this. This is very good news. I didn't realize they were doing Sherlock as well, because I'm a huge believer in scripting is the way to automation heaven, and especially in the electronics world, you're often doing similar analyses over and over and over again. So it would be nice to. We'll have to definitely keep our eye on that as that gets more mature. We'll let other people debug it the first couple of releases, but then we'll take a look at it.
Yep.
Yeah, good. So what else?
There's not too much more of this release.
Okay.
Just a couple of quick things. The parts library continues to expand, of course.
Great.
As users continue to provide feedback and they ask for Ansys to build out their own libraries, they kind of group all that together in a release. So I think the last figure that I have seen was that we're over 600,000 component definitions now.
Whoa.
Yeah, so it is substantial. It just makes it easier to use for everyone. You bring in a PCB that has some component numbers listed. It's nice when you don't have to comb through every single one of them and input your own definitions. So that's definitely an improvement, but it's one of those small kind of subtle things.
That's again the just quickly turning these things around is what game changer. I think that a lot of times when we wanted to do mechanical reliability and electrical components in the past, it was just we don't have the time. It just took too long. We can spin up a board and test it faster, and I don't think that's true anymore. I think that we can really do the virtual testing long before we spin a board up. So that's great news.
Yep, and that's always been, I'd say, the selling point of Sherlock is just being able to do these things fast and efficient.
In a consistent way. Yeah, it's
Right.
nice. Yeah, very nice. Okay, well that it seems like a fairly. I'm sure there's lots of bug fixes and things like that. We don't usually talk about those. Um,
Right.
anything else or any parting words for our listeners on the Sherlock world?
So I guess parting words. There is something in the near future that I'm very much looking forward
Oh,
to.
excellent. Okay.
It's something that you can do right now, but it is a little bit tedious. So when we're looking at very large, complicated PCBs, we're not always interested in the entire thing, right? Maybe there's a specific pad or a specific component, certain pieces of layers that is more interesting than stuff around it. So if you use a tool like Sherlock, or I guess any other tool that's not Sherlock, and you bring in your trace definitions and your vias for the entire board, it takes a lot of work to trim it down to just the region you actually care about.
Okay.
So Sherlock is trending in the direction where it has more, I would say, submodeling capabilities. So it should be easier in the next release or two to kind of focus in on specific areas of the board where you can maintain a really high level of detail, and then you have a coarse or large model around it, so that you do have that environmental relationship, but it's not nearly as expensive to solve and mesh and post-process. So definitely, Sherlock continues to improve. They always have something coming down the pipe. It's always interesting, useful stuff. I mean, people use this tool, for production boards.
Right.
It's very good at what it does. So they get great feedback from the field, and everyone can make use of it.
It's a really good point. We have customers that this is part of their process now, right? Before you release a board, you have to run it through Sherlock. Yeah, it's a really good point. It's come a long way, huge long way. Well, great. I really appreciate it. Always informative. And as mentioned, if you're not super familiar, if you're working on any kind of electronics components and you're not really familiar with Sherlock or Icepak for that matter, do reach out and let us know how we can help you get to know those tools and products a little bit better. And you may be doing things a way that works perfectly fine, but we may have a better way of doing it that you're not aware of. So I know that we've run into that with a couple customers where they've developed a fairly robust process around mechanical reliability, and then we showed them Sherlock, and they're like, "Oh my gosh, yeah, we need to change our process." So do reach out if you're in that boat. You think you might be. All right. Well, thank you, sir. I always appreciate talking to you. I hope you have a good rest of the week. It's Monday here in Phoenix, so have a great rest of the week, and we will talk soon.
Sounds great. Thanks, Eric. Have a
Thank
good one.
you. Bye-bye. I sort of summed things up with him there at the end, but don't need to add much. Do reach out if you do any type of electronics and you need to work on reliability. You should be looking at Sherlock. Josh would love to jump on a call with anyone interested if you're not in our territory for Ansys sales. We want to get more people using this tool. It's really a powerful thing. And that brings us to our commercial. Since our reboot, we talked about Ansys training. And I think it was 113. And then in 114, we talked about Ansys and our PADT in general. Today, I want to focus on our Ansys and FlowNext sales team. You do have a choice where you buy your Ansys from and where you get your frontline support. The good news is there are really no bad options. Ansys Direct or another channel partner, you will be taken care of. But there are better options, and we feel for customers in the southwestern United States, and that's from Texas all the way over to California and every state in between, PADT is the superior choice. Why? Well, we have an award-winning technical support team. You've met them on this podcast. You know they know what they're talking about. They will never be short or rude or treat you like they don't have the time to help you. Every support call is the most important, and we take that time to answer your questions and find the solutions you need. Also, our sales team is unique in that they are not really selling. Their goal is to find where PADT can help our customers and make sure you purchase the right tools. It's about working together to solve problems, not about pushing product. So next time you have a chance to choose your Ansys partner at your next renewal with Ansys Inc. or at your next job, because you may be moving on, going someplace else, and they need Ansys, please consider PADT as your Ansys channel partner. You will not be disappointed. All right, let's take a look at the Ansys stock. Yes. Ansys shares are up to $308.70. So nice gain there. This is the range it was last year about this time, and we'll talk a little bit about that in a second. Still a ways to go to recover from that, to recover back up to that all-time high of 406, but it's on its way. That is a year-to-date increase of 28% versus only 5.4% for the S&P 500. So Ansys is definitely outperforming the market. Now, I'm not saying it's a sure thing, but correlation is not causation. But we did start back up the All Things Ansys podcast, and the stock price is up. I don't know, just saying. Anyway, looking at the trailing 12 months, it was about 310 a year ago. It peaked at 327 in the end of March and hit a low of 201 in October. It's now at 308, or down 0.8% for the year. So the S&P is down 8.5% over the last 12 months. So still great trends, still outperforming, had that huge dip in there in the middle, and things are coming up. So let's hope this trend continues and the Ansys stock price keeps going up. So the big news to talk about on the Ansys news side of things is that Ansys did hold their meeting. They did release their Q4 financials and their 2022 complete financials. So highlights here. For the quarter first, they had $694 million in revenue in Q4. They had a 37.5% profit margin for $258 million in profit. And they had $818 million in annual contract value booked. So that's really, really good news. That's strong, forward-looking revenue coming. The quarter compared to Q4 of 2021, so 2021 compared to 2022 for the fourth quarter, was up 6% in revenue and a big jump in profit. So they obviously sold some stuff with a higher profit margin in there. For the year, they finally did it. They crossed $2 billion in revenue. So it's definitely something we're celebrating. It's a fantastic goal to meet. It's just a number, but $2 billion is a lot of money. And so we're really pleased to play a very small role in that. And hopefully others of you listening helped with that as well. So $2 billion, yay! That was on a $523 million in profit, which is a 28.7% profit margin. And they also booked around $2 billion in annual contract value. So that's good. So the revenue is up 8% and profit up is 15% year to year. So that big profit jump is really a positive thing to see. More profit means more money to acquire other companies, to invest in R&D engineers. So on the balance sheet for December 31st, 2021, it's always good to look at the balance sheet. Cash was down from $668 million to $615 million. So they're paying off some of that debt. And they also acquired some companies, as we talked about in the podcast. So that always takes the cash out a little bit, but it's still strong cash. Accounts receivable was up to $760 million from $645 million. So that's good, extra $100 million in accounts receivable for the year. And the long-term debt didn't really change. It was $754 million in 2021, and it's still with a few $100,000 difference, $754 million in 2022. So good there. No big increase in debt there. Another important thing to look at is R&D spend. They do report how much they spent on R&D, and you can do the math yourself. So it was $434 million in 2022, which was up from $405 in 2021. So I always like to see that number go up. That's better tools and products for us. And that's 21.5% of revenue. That's a sizable amount of the cash the company brings in the door is spent on that. So it's good to know, right? If they wanted their profit to go up, they could just cut R&D, right, for the quarter and make that number go up. But they're not. They're investing more in R&D because they learned over the long run that's where the money comes from, because people like you and me buy more stuff. As much as I want to take the return of this podcast as credit for this stock growth, I suspect that these numbers we've been going over, especially the increase in profit, are the real reason why it's going up. If you want to dig into the numbers yourself, definitely go to ansys.com/news-center. That's ansys.com/news-center. And you can find the press releases there, including the press release for this. And click in there and you'll find all sorts of stuff. Also, if you go to the investor page, you'll find even more information and even a recording of what Ajay and others had to say in the investor call. So if you're interested in that, do check that out. A lot of information there. The other bit of Ansys news worth sharing is for those of you who are professors doing undergraduate programs out there, Ansys has a grant program. They have $250,000 they set aside for the year to give in 10 25K grants to undergraduate programs that are redoing their curriculum. So it's money to pay for things to help redo the curriculum, to integrate more simulation, of course, Ansys-based simulation, into the curriculum. So if you want to do more digital twin, do more simulation, do more stuff with Ansys products, and you're looking for a way to pay for it, Ansys would like to help you get there. So do check that out. There's a press release, same place. The first set of proposals are due March 31st, so don't put that off. Get out there and read that. Learn a little bit more, see if it's a good fit for your university. Good stuff. Then PADT news, we don't really have any new news, so I'll skip that and go right on to the Ansys blog. So the first, for those of you that are new to the podcast or forgot after we were gone for so long, I usually pick 3 blog posts since the last PADT All Things Ansys podcast that I think are worth reading. There's plenty more there if you go to the blog.ansys.com. But here's the ones that I think are worth checking out. The first is the Ansys Microsoft Digital Twin Initiative reaches across the cloud to the edge. So, this is really a deep topic worth discussing maybe at some point. Everybody thought that using Internet of Things, we would get data, we'd upload the data to the cloud, we'd do all the computing up there, you'd run Ansys in the background for digital twin, et cetera, et cetera. The fact of the matter is, we can get compute power there right on the edge, right there at the device, and do these simulations right there. So this article is about doing that with Ansys and Microsoft together, the Digital Twin Initiative, to get more edge computing going. So check that out if you're into that sort of thing. Really great article called Turning Recycling Waste into Automotive Components Using Simulation. So there's a couple steps to this. They basically are saying, hey, you got all this leftover polymer, but the problem is that, and you want to use it for something. So in this article, they're going to use it for a crash absorption item for a vehicle, right? So basically a bumper, right? So the big problem is that you don't have the consistency of material properties, right? You've got all this waste material and how you process it, how it was used, where it came from. It's all variable. So you get a big variability in your material properties. So step 1, use Granta to understand that variability, understand which of the different recyclable materials you've got in your inventory you should use to combine. So you can use the Granta tool to kind of design and then understand your material properties. Then, once you've got that range of properties, you can use basic tools, but different tools, to see how that variability material works for you. And they use OptiSlang to do that. It's a pretty good example of using OptiSlang to set up a bunch of simulations to look at this variability. And then they take a look at doing crashes with LS-DYNA. So again, this doesn't have to be a simple analysis. It can be a full, nonlinear explicit dynamics simulation. So they did a crash with LS-DYNA, looked at the energy absorption. I think that was what they're trying to optimize on, and figuring out how to change the design so they could use the recycled materials to make this bumper. So great example. Very, very cool. That's my favorite one of all these. And then the last one is kind of neat and kind of a personal one for me, because I find drones, these quadcopter drones, super annoying. Their size is such that the noise they give off, the acoustics they give off, is a wavelength that is pretty annoying. In fact, it's what they consider, by reading this article I learned, they consider ear ringing range. So it makes your ears ring. So they did a simulation using CFD and the Ansys sound module to not just calculate what the noise of a quadcopter is going to be with all the interference and the passing frequencies and all that stuff, but also what it actually sounds like. So put it through a speaker and is it annoying? And then change the design to see if you can get rid of that ear ringing sound. So a great application. Yours may be slightly different, but if you've got an annoying noise problem, this is how you can use the Ansys suite to capture what the excitation is and then what the noise actually sounds like. So that's the Ansys blog. Let's talk about the PADT blog. So the best read we've got out there is Pam Waterman. Our very own Pam Waterman was involved with a group of women called the Girl Gang Garage. And they basically do builds. They take old vehicles and they make them into new, cool, modern, kind of hot roddy type vehicles. And the project they've been working on for several years, and we've talked about on the podcast before, where PADT has been helping, is to take an old Volvo, 1960s Volvo, and the new electric Volvo, and take the powertrain from the electric one and put it into the old one, and then make some cool changes to the body design. It's super slick. It's called the Maven. Iron Maven. Actually, take that back. Iron Maven. And it debuted at a big car show this year. And there were a lot of 3D printed parts that we helped on with that. We did some scanning. We did some 3D printing. It's just a cool application. Women in the world of automotive, about using advanced technology for these kind of hand builds. It's a really cool article. So do check that out. Not a lot of Ansys stuff in there, but it's really cool. So check that out. And then on the Ansys side, Cynthia did publish Cynthia De La Rosa, who's been on this podcast, did do a great blog article called Access Powerful Non-Sequential Ray Tracing in Ansys ZMax Optic Studio 2023 R1. So this is a capability. Non-sequential ray tracing is an advanced capability. It was only available with more advanced licensing. With the integration with Ansys and new licensing schemes, it's available to almost everybody now, so you can get to it without having an advanced package. Do check that out. It's really important if you're doing optics. Upcoming events-wise, let's go ahead and bring up the PADT events page and see what we have on the agenda. So coming up probably after this podcast, before this podcast goes out, on Wednesday, March 8th, today is the 6th, our Flownex team is doing a competitive advantage of 1D, 3D coupled simulation. So how to use basically Ansys Fluent or Ansys CFX with Flownex to get a competitive advantage. Where to use the 1D part, that's Flownex, and when to use the 3D part, which is the Ansys, to get a better solution faster. Really useful. Definitely check that out. You don't have to listen to any of these live. They're all recorded. They're all being saved over on our platform for such things, which the name of which in my befuddled state is escaping me. It's called Bright Talk. So go to brighttalk.com, look up PADT. You can see all of our webinars there. You can watch them live or you can watch them recorded. Then on March 15th, we're going to do a 3D design updates in Ansys 2023 R1. So we're going to talk about all the 3D design tools. And then we've got a 3D printing webinar on the 22nd, which is the optimized jigs and fixtures with additive. So that's a pretty cool one for that group of people. And then if you are local here in Arizona, we will be at the Arizona MedTech Conference on the 22nd. The Arizona Buyerpreneur Conference on the 24th. We're a sponsor for both of those. And then just to let you know, in case you're planning, because you should have your hotel. If you don't, you're going to be living out in the boonies. The 38th Space Symposium is coming up in mid-April, and we will be in the Arizona booth again. We hope to see more Ansys users at that like we did last year. So that's a great event, one of my favorite of the year. So that is upcoming events, and that's our podcast. So I want to thank everybody for taking the time to join us. Hopefully you found it informative, and hopefully I will be thinking straighter when we talk again in a month. So don't forget to subscribe to our newsletter to find out what's going on with PADT at www.padtinc.com/opt-in. Do spread the word. Do subscribe to this podcast on whatever podcasting tool you do, and don't ever hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 115. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employer. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.